Good afternoon everyone. So today I am going to give the lecture on the calorific value and its determination. So the calorific value relates with the fuel. Fuel is a combustible substance chiefly containing carbon, and sometimes it contains some other material like sulfur, water or phosphorus. So beside this carbon, so fuel consists of these elements. The fuel on burning produces large amount of heat that can be used economically for domestic and industrial purpose like cooking, transport and some other activities. It plays very important role in daily life. Fuel burns in the presence of oxygen and it gives some waste product and it generates the heat. The heat generated keeps our body running and enables it to work. Human body thus becomes a heat machine and requires intake of fuel for the release of heat energy. The fuel used by human being is food along with oxygen. So now the fuel used in our body is the food which I have taken early in the morning or yesterday. So it burns with the oxygen, that is I am able to talk to you and that I am able to come here. So the heat energy keeps our body running and enables it to work. The food which we are taking, that is generally carbohydrates or the polymer of the sugar molecule. So here in the syllabus we deal with the fuel which is keeping the machine work or the industry to work. So on the basis of their occurrence, there are two types of fuel, natural or primary fuels. The fuel which is produced in our earth by natural way, that is called a natural fuel. For example, wood, peat, coal, petroleum, natural gas, these are all made by the natural way and they cannot be made in the laboratories or in the factories, and they can be made in unnatural way, but the cost of manufacturing is so much high that natural or primary fuels are cheaper. So there is no any fun to make these fuels in the factories or in the industries. So another one is these artificial or secondary or synthetic fuels. These fuels are prepared artificially from the primary fuels. The examples of the synthetic or artificial fuels are coke, kerosene, oil, petrol, coal gas, producer gas, etc. On the physical basis of fuel, the fuels are divided into the three categories, that is one solid and another one is liquid and another one is gases. So both primary or artificial solids fuel is again divided into two, that is artificial fuel and natural fuel. Similarly, liquid, the natural mineral oil is petroleum products which is obtained from the earth or mineral oil, while artificial or synthetic fuel is petrol or diesel. Similarly, the biogas obtained is a natural fuel, while LPG or coal gas, they or producer gas or water gas, they are artificial or synthetic fuels. On the basis of their physical state, natural solid fuels are wood, peat, lignite, bituminous or anthracite, etc. And artificial solid fuels are wood, charcoal, coke, etc. So, there are artificial fuel or natural fuel. Similarly, in the case of liquid fuels, natural liquid fuels are crude petroleum product which is obtained in the center of the earth, while the artificial liquid fuels are petrol, diesel, kerosene, coal tar, etc. So, in the case of gaseous fuels, natural gaseous fuels are natural gas or marsh gas, while the artificial gaseous fuels are producer gas, water gas, coal gas. These coal gas are produced by the destructive distillation of the coal product. When coal is heated in a test tube, so the coal gas is produced, and that is artificial or synthetic fuel, while natural gas or biogas obtained from the waste product of the cow dungs or the fodder material or marsh gas, they are natural gas, they are natural fuels. So, when the fuel burns in the presence of oxygen, it gives waste product and heat is generated. Combustion is a chemical reaction in which a substance combines with oxygen at a rapid rate to produce heat, light and flame. A common example of combustion is burning of coal in the presence of oxygen to give carbon dioxide and 97 kilocalories of heat. So, generally coal is solid and oxygen is present in the atmosphere. So, when we ignite the coal, it gives carbon dioxide as a gas and the heat generated is approximately 97 kilocalorie of heat is generated. So, calorific value of a fuel. This calorific value of the fuel depends upon the constituent in the fuels, and calorific value is defined as the total quantity of heat liberated when a unit mass of a fuel is burnt completely. So, for example, if 1 gram of carbon burns, how much heat it will generate, that is known as the calorific value. So, 3 types of units are of calorific values. In CGS system, the units are calories per gram for the solid or liquid fuel, or for gaseous fuel the units are calorie per centimeter cube. In MKS system, the units are kilocalorie per kilogram of the fuel, and in the gaseous, that is kilocalorie per centimeter per meter cube. In British thermal unit, that is 1 British thermal unit per pound, and gaseous fuel, that is British thermal unit per feet cube. In CGS system, calorie is the amount of heat required to raise the temperature of 1 gram of water through 1 degree centigrade. So, calorie is the amount of heat required to raise the temperature of 1 gram of water through 1 degree centigrade. So, if the temperature normal temperature is around about 24 degree centigrade, if we will take 1 gram of water and raise the temperature through 1 degree centigrade, it means 26 centigrade. The amount of heat it consumed, that quantity is equal to the 1 calorie, while in the MKS system kilocalorie is the amount of heat required to raise the temperature of 1 kilogram of water through 1 degree centigrade. Only the difference is the amount of water. Here the amount of water is 1 kilogram, while in the CGS system the amount is only 1 gram of the water. In FPS system the units are British thermal unit. So, British thermal unit is the amount of heat required to raise the temperature of 1 pound of water through 1 degree Fahrenheit, and 1 British thermal unit is equal to 252 calories or 0.252 kilocalories. So, they are interrelated with each other. In SI system the unit are joules and 1 calorie is equal to 4.184 joules. The calorific value of a fuel depends upon the constituents present in the fuel. Fuel should have high calorific value. The fuel which is having high calorific value, it gives the more energy or more heat to us. It should give large amount of heat. So, calorific value of few fuels are natural gases having calorific value 12,000 to 14,000 kilocalorie per cube, while the wood as compared to natural gas, it is having calorific value of 3500 to 4500 kilocalories per kilogram, while the black coal, it is having little bit higher calorific value than the wood. The reason why black coal is having more value than wood, that in the wood there are some water constituent or some waste materials are present in the wood, while black coal contains only the carbon. That is the why it is having more calorific value than the wood. While the LPG, it is having 27,800 kilocalorie. So, again it is having more calorific value than the natural gas. Why LPG is having more calorific value? Because in natural gases there are some traces of water which will consume the heat generated by the methane. So, other constituents which consume the heat, that are present in the natural gas, but in the case of LPG there is only pure fuel is present, that is why LPG is having more calorific value than the natural gas. The fuel should always have low moisture content, as moisture reduces the heating value or the calorific value. As I have already told that black coal is having more calorific value than the wood, the difference is about 2000 kilocalories per kg. So, the fuel also contains some non-combustible material. So, there are some waste products are present in the fuel and they generate the ash. Ash causes the hindrance in the flow of air and heat, and hence it decreases the calorific value. Lower the content of the non-combustible material, better is the quality of the fuel. So, the fuel which is having ash content in it, that is giving low calorific value. So, peat, it is having more ash content, that is the reason it is having 5000 kilocalorie calorific value, while the anthracite, which has low ash content as to compared to peat. In the peat there is 4% ash content, while in the anthracite there is only 2% ash content, and that is the reason. And see from this slide that the calorific value of anthracite is 8600, while the calorific value of the peat is only 5000 kilocalories. The highest temperature obtained with the fuel is known as pyrometric burning effect. A good fuel should have high pyrometric effect. Gaseous fuels have the highest pyrometric effect. Generally, all fuels contain carbon and hydrogen and other materials. Combustion of these fuel produce heat and waste. Generally, all the fuels contains carbon. So, carbon is the main constituent which gives us the heat. Combustion of these fuel produce heat and waste. So, if some other material is present beside the carbon, then waste is also obtained, and further the heat is also generated. If the products of combustions are condensed to room temperature, the latent heat of steam also gets included in the measured heat. The gross calorific value may be defined as the heat produced when 1 unit of the fuel has burnt completely and the products of the combustion are cooled to room temperature. So, the gross calorific value is the total heat produced when 1 unit of the fuel has burnt completely and the products of the combustion are cooled to room temperature. Under normal conditions, the water vapor and moisture etc. are not condensed and escaped as such along with the hot gases. So, if there are vapor and moisture contents are present in the fuel, then the fuel is having low calorific value. So, and lesser amount of heat is available. Lower or net calorific value may be defined as the net heat produced by burning unit mass of fuel, and products of combustion are allowed to escape. So, the fuel which is having more moisture content or more ash content, they have lower calorific value as compared to the fuel which is having lesser moisture content or lesser waste product. So, there is a comparison of calorific value of some fuels. So, anthracite which is having 4% water, the calorific value is 36, while coal tar fuel it is having calorific value 36 to 41 kilocalories per kilogram, while the general purpose coal it is having 32 to 42 calorific value, while the high volatile cooking coal it is little bit have high calorific value than the other anthracite or coal tar. So, low temperature coke it contains 15% of water. So, the calorific value is due to the more water content, the calorific value is 26, while the medium volatile cooking oil which is having 1% water, the calorific value is 37. So, highest because it contains only 1% of the water. So, steam coal, it also contains 1% of the water. So, the calorific value of the steam coal is also 36. So, there are some calorific value of the liquid fuels. So, diesel fuel is having 46, while the gas fuel it is having 46 also. Heavy fuel oil, it has calorific value 43. Kerosene, this is having a calorific value 47. So, light distillate. So, all these are byproducts from the mineral oil obtained from the earth. So, these diesel, gas oil, heavy fuel oil, kerosene, light distillate, petrol. So, all these are obtained from the distillation of the mineral product. So, petrol is having the highest calorific value. Beside this, there are some other material present like ethanol or methanol. Ethanol is obtained from the fermentation of the waste sugar product, and the calorific value of the ethanol is 30 kilocalories per gram, while the methanol it is having 23. Similarly, peat, which contains 20% of water, the calorific value of the peat is 16. Wood, this is natural fuel, solid fuel, and generally it contains 15% water. So, the gross calorific value of the wood is 16. The calorific value of the fuel is measured by the bomb calorimeter. So, bomb calorimeter is used for the measurement of calorific value of fuel oils, gaseous, gasoline or petrol, coal, combustion waste, foodstuffs and building materials, etc. Bomb calorimeter is also used for energy balance study in ecology and study of nanomaterials, ceramics, zeolite. Bomb calorimeter is helpful to study thermodynamics of common combustible material. So, generally the bomb calorimeter is used for the measurement of the calorific value. So, the principle of the bomb calorimeter is that a known amount of fuel is burnt completely. So, we weigh the fuel and then burnt that fuel into the bomb calorimeter. Thus heat produced by burning of the fuel is absorbed by the water and by the bomb calorimeter. Quantity of heat produced by burning unit mass of fuel is calculated, and by this we will come to know the calorific value of the fuel. So, this is the model of the bomb calorimeter. So, generally it is made up of a steel and it has a stirrer. There are two electrodes are also present, and there is a thermometer is also present which measures the temperature. There is also a inlet of oxygen, because without oxygen we cannot burn the fuel. There are some fuels are present, and there is some crucible on which we will hold the on which we can place the fuel. So, this bomb calorimeter is dipped into the water, and when we passed the electric current, the fuel burns completely, and we will know the rise in the temperature, and by knowing the weight of the fuel, and uh, by knowing the uh, raise in the temperature, we can calculate the calorific value of the fuel. So, bomb calorimeter is generally a strong stainless steel container resistant to high temperature. It can sustain high temperature. A lid is provided on the top of the bomb calorimeter, and that lid can be screwed firmly on the bomb that no heat can escape to the surrounding. Lid is provided with two electrodes and an oxygen inlet valve. So, the oxygen is the necessity for burning the fuel. So, the lid is also provided with the two electrodes, because a current is passed through the lid with these electrodes, and the fuel burns with the help of these two electrodes. One of the electrode is provided with a ring to hold the silica crucible. So, the fuel is placed in the silica crucible because silica is unreactive with the fuel. Generally, it will not react with any type of the fuel. Bomb is placed in a copper calorimeter having a known weight of water. So, we will place the fuel by weighing it and put the bomb in the copper calorimeter, and into the a big container which is having water, and the weight of water we also know. Copper calorimeter in turn is surrounded by an air jacket to prevent loss of heat to radiation. The heat generated in the calorimeter is not allowed to escape to the atmosphere. Only if heat is produced, then only water can absorb the heat only. The calorimeter is provided with a stirrer and a thermometer. So, the purpose of the thermometer is note down the initial temperature of the water and the final temperature of the water after burning the fuel, and stirrer it rotates the water to get to note down the uniformity for the uniform transfer of the heat. Known mass of fuel is taken in the silica crucible. So, then fine magnesium wire touching the fuel sample is stretched across the electrodes. Oxygen supply is forced into the bomb till a pressure of 20 to 30 atmosphere is reached. So, the initial temperature of water we will note down, and after burning the fuel, then the final temperature is also known. When the current is switched on and the fuel in the crucible burns with the evolution of heat, ultimately the heat produced is absorbed by the bomb calorimeter. That bomb calorimeter passed the heat to the water, and by passing that heat to the water, the temperature of the water rises. So, that we should know the total temperature rises of the water. So, by doing the calculation we can come to know the calorific value of the fuel. So, if we will take x gram of fuel in the crucible and W capital, that is the total mass of the water